Excellent. Let's kick off the show. Thank you for joining us. Good morning. My name is Michael Goldberg with CED Greentech. Today we're gonna sit down with Sungrow to talk about a 350 kilowatt commercial string inverter. We're gonna take a deep dive into this new product. Before we get started, there's product sheets available in the handout sections on the control panel. If you take a look there, you can get some a data sheet about this new product. At the end of the webinar, we're going to do questions and answers. Also, a recording of this training will be sent to all people that register. So don't be concerned, you'll get a recording after the event. Once again, my name is Michael Goldberg. I'm the Senior Marketing Manager here at CED Greentech. We are the largest solar distributor in North America. I don't know if you know us, but if you don't, I invite you to come talk to us. We have 70 plus locations nationwide, servicing the entire country. Each location covers basically a 200-mile radius around the location, but we have fantastic coverage. We sell all kinds of solar products, everything that you need, electrical services, everything you need to do renewable energy equipment. We do a lot of storage these days. So please come talk to us. We have a fleet of our own trucks that roll daily. So we will deliver things to the job site or your location with our own trucks. It's pretty extraordinary. Today I'm joined from Nick Valcho, who is the application engineer manager at Sungrow. Nick, welcome, and thank you very much for giving this introduction to this new product.
Yeah, absolutely, Michael. Thanks for having me. And on behalf of Sungrow, I'd like to thank everybody that's in attendance here. The 350 is something that we're really excited about. So really excited to introduce this new product into the C&I market with CED here. And as Michael said, we're gonna have some time at the end for questions and answers. So if you do have some questions, please type it over in the questions field, and we'll try and answer as many as we can by the end of the presentation here. Okay. So the SG350HX is the world's most powerful string inverter. Its predecessor was the SG250HX-US, and the official model number when the 350 is released next year will be the SG350HX-US. It's already installed in several global markets, and there's already, I think, close to 15 gigawatts of this product installed globally. So it definitely has a large footprint and a good track record. So we're really excited to bring it here to the North American market. All right. So we're going to talk first about the challenges that were presented in 2019 and how we're kind of navigating those and how those challenges evolved through 2021 and what we can expect to see in 2022, and specifically how the SG350HX is geared and designed to address those challenges. So in this era of escalating grid parity and plateauing levelized cost of energy, or LCOE, subsidies are increasingly rare, and the price fluctuations of raw materials, which we're all undoubtedly familiar, including silicon, glass, copper, and aluminum, things like that, have led to an increase in the cost of straight system materials. So Sungrow's new product development aims to ensure that our customers' internal rate of return will not decline and ideally continue to grow despite the tumultuous conditions that we're experiencing in the industry. The growing capacity of photovoltaics, coupled with the volatility, unpredictability, and emergence of new energy, are having a progressively adverse impact on the power grid. So as a result, for us that are technically minded out there, short circuit ratios of power conversion equipment are gradually declining. So we're designing our inverters with adaptability in mind to better support the grid against these more common conditions. Continuing the evolution of this grid reinforcement by PV inverters is now a problem that we're actively solving, not one that we're retroactively trying to keep up with. And it's definitely one that is Sungrow's charter as we navigate this ever-changing ecosystem of renewable energy generation. So a quick introduction to the SG350HX. Just taking some highlights from the data sheet here. We're going to have basically two different flavors of inverter to offer the market, but the standard offering is going to have 16 MPPTs with a max efficiency of 99%. In order to meet the demands of the high power modules that are starting to penetrate the market that we're seeing, we're going to be offering 20 amp per string maximum current tolerance to be able to get your DC to AC ratio kind of in that sweet spot where you want to see it for those high power 182 and 210 millimeter modules that are coming out. The SG350HX is really optimized data exchange system with a tracker, which will give kind of micro adjustments on the tilt of tracker systems, which can improve the yield. We're really focused on lowering cost, right? So some of those features include the queue at night function. Power line communication is something that we're really looking forward to deploying here in North America. Other global markets have it, but there's some challenges here in North America for us to deploy the PLC, but we're currently working through those challenges to bring it to market. And along the lines of PLC, we are going to be offering smart IV curve diagnosis and active O&M. So you'll get a full picture and some really detailed resolution into the health of your DC. Safety is another consideration. We're always looking at ways to improve the safety and the reliability of the inverters. So with our direct input design, we're still maintaining the architecture of having only 2 strings per PowerPoint tracker. So you really don't need to worry about reverse connections and overcurrent devices that you would need in systems that have more than 2 strings per PowerPoint tracker. Integrated DC switch, there's actually multiple DC switches that are going to be integrated in the inverter. And the unique thing about these that we'll cover a little bit later is that as opposed to just detecting a fault and having the inverter DSP or ground fault detection circuit be responsible for de-energizing in the event of a bolted fault or a short, the DC switch operates autonomously. So that's a pretty cool feature. And introduced in the 350HX, we have not only DC insulation monitoring, but AC insulation monitoring as well. And in the introduction slide, we talked about the short circuit ratio, getting to be down around near 1.16 or so. There are areas in North America and definitely globally where we're experiencing extremely weak grid conditions. So having an inverter that can support that not only in a timely fashion but a robust fashion is something that is really required, especially with the evolving grid support demands of the new codes that are coming out. As with its predecessor, the SG250, the SG350HX will still be a 1500 volt inverter. Pretty much all of the highlights that you see here, the max PV input voltage, min PV input voltage, and startup input voltage, nominal, the MPP voltage range, all of that is pretty much identical to the 250. The big difference is the number of independent PowerPoint trackers. So we do have 12 is offered as standard, but then we're also offering a different version of the inverter where you can have either 14 or 16 MPPTs to accommodate those larger wattage modules. And then with that, the max PV input current is going to be 40 amps per PowerPoint tracker with the 12 MPPT option, and then 30 amps per MPPT with the optional 14 or 16 inputs. So that brings our max DC short circuit current per PowerPoint tracker to 60 amps, as opposed to the 50 amps that we realized with the SG250. All right, and this is just kind of a side-by-side visual comparison. The 250 is still an incredible machine, and it's in very high demand here in the US, pretty much all across North America. But I wanted to have a side-by-side comparison so that everybody can see the difference between the 250 and the new 350 that's going to be released sometime early 2023. Now moving to the AC side, the SG350HX is going to have a maximum AC output power of 352 kVA at 30 degrees C. And then we have a linear D-rate curve, so 320 kVA at 40 and 295 kVA at 50 degrees C. One of the improvements in the 350, which to be honest, from an engineering standpoint, I didn't really think would be easily achievable, but that's why our research and development department is the best in the industry. We were able to improve the cooling efficiencies of the new 350, so we can achieve greater CFM, which means greater cooling efficiency across the backplanes and the substrates of the IGBTs and the heat sinks, with less parasitic power used. So the efficiency of the 350, the total weighted efficiency, is even higher than the 250. The max AC output current is going to be 254 amps. Nominal AC voltage on the output is going to remain the same at 800 volts. Three-phase with a PE. You can also land a neutral if the project requires it, or your transformer configuration requires the landing of a neutral. There are certain considerations for the PID mitigation that's in there. So with certain module types, if you're required to use anti-PID, then make sure to discuss with us or with CED Greentech about the specific transformer configuration if you're going to be using the active anti-PID feature. And if you're not familiar with PID, let us know in the questions and we can go over that at the end. We definitely meet the IEEE 1547 total harmonic distortion limits and the DC current injection, no problem there. And then the power factor, our reactive power curve is still the same as the 250, 0.8 to 0.8 leading and lagging. As far as protections go, we do still have DC reverse current protection, AC short circuit protection, leakage current. We have grid monitoring, of course, as well as some pretty sophisticated grid support features. We do have a DC switch, but there is no AC switch on the unit, and I'll go over that a little bit later as well. PV string current monitoring. The Modbus map with the inverter has the capability of monitoring string currents and voltages at an input level, so DC1 and DC2 for each MPPT, both positive and negative, or you can just monitor on an MPPT level. So depending on what kind of bandwidth you want to use on your monitoring platform and how many registers you want to have your SCADA provider pull, you can still get down into the individual input level to monitor your DC health. Q at night function is still integrated, and that's becoming a more and more popular request from projects because the reactive power at night in areas where the grid is weak again is something that utilities are starting to ask for a little bit more. And there's also a slight influx that we've seen in the trends across projects in the CNI space, definitely in the utility space. But there's an influx of monetizing that reactive power at night. So there are some incentives for developers and operators to provide reactive power at night, and the 350 has that capability. As with the 250 and even the 250's predecessor, the SG125, we do have anti-PID and PID recovery, as I mentioned before. Now the data sheet says that it's optional. The only reason it says optional is because it's a toggle option. that's in the HMI app. Every inverter comes equipped with that particular hardware and software to control your PID. And then, as with all of our string inverters, we have type 2 DC and AC surge protection. I'm not going to go over every single one of these features of the general data, but the weight is 242.5 pounds. It's really not that much heavier than the SG250 was. So from a power capacity versus weight ratio, this is definitely top of the market. It is a NEMA 4X rated inverter, obviously, for outdoor installation, and the corrosion protection that we have on the SG350 is C5. So it is C5 rated as standard. Some of our competitors out there and other string inverter manufacturers just have C4 protection, which is more than enough for most projects. But when we incorporate C5 anti-corrosion rating into the powder coating and some of the materials and gaskets that are used to protect the electronics of the inverter, it really does expand the diameter of your installation, right? So you can start looking at projects that are more coastal, looking at projects that may be in a caustic environment like wastewater treatment facilities or landfills, places like that. The communication is still going to be RS-485 by standard here in North America. And as I mentioned at the top, we are going to be working on releasing a power line communication solution for North America before the end of the year. DC connection type is the same as the SG250. It's going to be the Staubli MC4 Evo 2 connectors, maximum of 10 gauge, but you can go with 8 gauge as one of the options there. That will, help mitigate some of the voltage drop that you're going to have if the DC runs are a little longer than ideal. So let us know in the design phase if 8 gauge is something that you're going to be needing for your project. And then all of the compliance is there. We're really ahead of the curve with a lot of the new standards and certification requirements that are coming for the market. UL 1741, 1741 SA, getting listed with the CEC is going to be a topic and a task that's at the top of my list this year. So once we get all of our testing documentation in order, we're going to submit it right away so that we have the SA 8 through 18 certification listed and the E5000 and CSIP requirements for all of the smart inverter listings with the CEC. Obviously, IEEE 1547, the new standards that are going to be released, we're going to be testing to that. I actually think that we have already tested to that. We're just getting our testing documentation in order for that. Rule 21, obviously, and then 1699 Bravo for the UL. And then we talked about grid support. We're going to be talking about all these functions a little bit later in the slideshow, so I'm not going to mention them now. But the entire system solution, when you bundle it together, here's a pretty rudimentary diagram here. Obviously, we're all professionals in the solar world, so we know exactly what we're looking at. But Sungrow's goal is to incorporate the 350 into a total system solution, right? We want to look at everything from the DC health of your modules, really tweaking the tracker accuracy to help increase the yield of the system. And the SG350HX will be a sensor and a feedback device that's capable of optimizing a tracker solution. The 350, as with the 250, is meant to be installed in a distributed generation format. So the optimized block size that we're looking at for North America is right around 4.2 MVA, somewhere thereabouts. You obviously have room on either end of that point with the 350. And increasing safety, not only for operators, but for technicians and O&M personnel, as well as safety of equipment and land, land and project square footage is becoming more and more precious. So we want to make sure that we're being good stewards of the square footage that we're taking up out in the field. So by improving safety, we're investing in the confidence that's being given to Sungrow. So the active braking fault is a redundant protection design that we have built into the DC switch there. So safety is definitely at the forefront of the design. The multi-dimensional integration that we're talking about incorporates everything like I've been talking about, from the new high power modules that are starting to penetrate the market here, that we're seeing more and more projects being specified with. Tracking optimization, the deployment of an online IV curve trace function that will help increase total yield with everything all taken into account by about 2%. And the grid support features, volt var mode, frequency watt mode, all of the advanced grid support functions that are starting to be required on these projects is going to be already integrated in the 350 and ready to deploy in the field. So getting a little bit more into the weeds here with the intelligent DC trip switch, it automatically is going to cut off the fault, as I mentioned, for increased safety. So when the inverter detects an abnormal condition, it's not only going to trip the DC switch autonomously, but it's going to remove any voltage that may exist on that line so that we can safely troubleshoot and de-energize that entire circuit. So it operates in concert with the DC current detection circuit, the DSP or the intelligent controller, and the DC voltage detection circuit. So everything all combined there, it's kind of a suite of protection. And as I mentioned, the SG350HX is going to have more than one DC switch. It's probably going to have 4 of them that are kind of divvied up to help break up the MPPT and reduce the incident energy on all of that. So here is kind of a comparison. On the left-hand side, we have Sungrow's SG350 design, and then on the right-hand side is a different high power capacity inverter. The cables, so we're just going to kind of go through the features here and the differences in the design with Sungrow's 2 strings per PowerPoint tracker design as opposed to 5 strings per PowerPoint tracker design, and the benefits there. So the cables and the PV modules only need to withstand 1 time the short circuit current on the cables and the PV modules, even if there's a reverse current detection. So there's no need to configure any overcurrent protection devices or install fuses with our solution. So that's going to help save on CapEx and OpEx later on down the road, because those fuses aren't going to have to be inspected, maintained, or replaced. The intelligent DC trip switch is used as a redundant protection. Like I mentioned before, it's going to break the faulted current under a 0 current condition, which increases the safety for operators as well as reliability of equipment. So if we look over on the right-hand side, some other inverter manufacturers that are releasing high power capacity inverters to the market, and they still are going to require multiple strings to be connected to each MPPT. So in this particular instance, the DC overcurrent protection device has to be fuses or a circuit breaker. A DC trip switch cannot be used as an overcurrent protection device. And because per code, because this solution has more than 1 string connected to a single PowerPoint tracker, it does have to have one or the other. And in this particular example, you can see that PV input number 5 has a fault on there. So in this instance, that input, PV circuit number 5, has to withstand 4 times the short circuit current. And there is definitely a risk of a burnout, which is code for a thermal event or something bright and flashy and melty, and that's something that we don't like to see. The DC switch there in this particular scenario would have to bear 4 times the short circuit current, which would be roughly 80 amps or so, and potentially could see up to 3,000 volts of DC at the breaking point, if that current is reversed in a ground fault condition. So the switch cannot be used in a scenario like this. So with the multiple PowerPoint trackers that we have integrated into our design, all of those considerations are kind of thrown out the window. Don't need to worry about that. It's a very, very simple design. 2 PV inputs, 2 positives, 2 negatives per PowerPoint tracker eliminates the need for fuses and overcurrent protection devices. We all know the importance of monitoring the DC health, and for years, Sungrow has been kind of an industry leader as far as insulation monitoring goes. We've always employed kind of a 2-tier approach to our DC health monitoring. There's been a residual current detection and insulation resistance monitoring. Insulation resistance monitoring kicks in the morning before the inverter enters its solar duty cycle. And as the inverter is going through its countdown cycle, it's going to measure the insulation resistance to ground. And it's the 350 is still going to do that. That's going to be a staple, obviously because it's required, but because it's kind of a best practice as well. The addition to this is that we're going to be offering that same type of monitoring on the AC side to do AC insulation monitoring on the cables that are connected to the AC wiring box on the side of the 350. So that's also going to reduce the amount of equipment that's necessary on the secondary side of a medium voltage transformer. So we're going to be really reducing the amount of CapEx consideration in a project that's going to incorporate the 350. And all of these thresholds can be manually set, right? So if you have a site where you're starting to kind of see some insulation resistance issues, you can lower that value as a troubleshooting mechanism, and it'll really help you narrow down and find out exactly what portion of the array you're experiencing those insulation resistance issues in, so that technicians can get pointed in the right direction, as opposed to finding a needle in a haystack in a full array. And the other really cool thing about the advanced insulation monitoring that we're offering, both on the DC side and the AC side, is that we have kind of a predictive loop that's incorporated into the inverter software. So it's going to remember the values that it measures each day, and compare that to a certain time period before, and start to predict breakdown of equipment, and give you some intelligent recommendations for operations and maintenance. We talked at the top of the presentation about the inverter being optimized for the 182 210 millimeter wafer PV module that's coming out, or is already out, and we're starting to see in more and more projects. The challenge with these is that with the inverters that are on the market right now, our short circuit current, our max input short circuit current doesn't really allow for a very high DC to AC ratio. Sometimes depending on the module selection and the string size, based on the geography and the square footage that we have to work with on certain projects, we're not really able to achieve a very high DC to AC ratio. With the 350, we're really recommending the sweet spot to be somewhere between 1.3 and 1.8. Central inverters, you can see DC to AC ratios as high as 2.0. But that's because of the robustness of the equipment, right? So because we're offering 15 amps per string or 30 amps per MPPT, and then 20 amps per string or 40 amps per MPPT, with that, you're still going to be able to achieve a really efficient and strong string design at that 1.3 to 1.8 DC to AC ratio. With still, utilizing 16 or 12 MPPTs. So we really are optimizing the selection, and we're trying to make it very easy, you know, between those two different variations of module that are coming out. And that large capacity ratio it's also going to further reduce your system cost, and the power generation curve is going to be a lot smoother utilizing this type of MPPT and string design. So a couple of things to boast about with the inverter is that back in 2016, our online IV curve scan obtained TUV certification, and we were the first inverter manufacturer to achieve that. And we're now the first inverter manufacturer to have achieved the level 4 certification for the online IV curve trace. And basically that just that shows that the accuracy is continuing to increase with that online IV curve scan. And for those not familiar with the online IV curve scan, it basically takes the place of a manual solmetric measurement, you know, where you would have to go out to either a combiner box or, in the instance of a 350 or a 250 HX inverter, you know, determinate all of the DC inputs and then connect each one of those string inputs to the solmetric measuring device. This usually requires 2 people, you know, 2 highly trained technicians to go out to the field, perform this work. So you're not only paying for the truck roll and the labor and usually the equipment rental for the solmetric device, but you're also paying for the reports, the analysis, and you're also losing revenue on inverter downtime because this has to be done during the day, right? So with the online IV curve scan and diagnosis being as accurate as you know, 90+%, we're really able to give you a highly granular insight into your DC health. Okay. This is kind of a cool slide here, and I really, and I'm not trying to tease. I don't think we're going to get this here in North America anytime soon, but in other global markets, the SG350 has been coupled with a Sungrow branded module cleaning device, and the 350 controls all of it. Controls the robotic cleaning, the periodicity of that cleaning based on occlusions or shading or dust, stuff like that. And so I'm hopeful and keeping my fingers crossed that we're going to get something like that here in the US sometime soon. And when we do the 350, we'll be ready to offer command and control of all of that. And the test site, if we were looking over here at the right-hand slide, this particular 120 megawatt project in China, when it was coupled with the online IV curve scan, the intelligent cleaning, and the predictive O&M, it increased generation by more than 2% from its previous year. Now 2% might not sound like a lot, but when you factor that into the aggregate and extrapolate that over the life of the project, it is significant. Michael, can we get the next slide? Thank you. And quickly, we've discussed the active grid support to meet the requirements of new power systems. This is just kind of a quick visual about what that means, right? So we talked about the short circuit ratio getting down around 1.16. Definitely areas globally are experiencing you know, reduced strength in the grid because of these emerging technologies. And it's up to us, you know, it's up to the renewable energy providers, most especially in solar and in wind and energy storage, to be able to provide dynamic support to strengthen the reliability of the grid, because we are by a far margin the most I guess the biggest slice of the pie when it comes to new power being brought online. So it is our responsibility to help improve, not maintain, the stability of the grid. And by incorporating some of these features and grid control functions of the command and control software of the 350 as well as the 250, we are able to realize that. Okay. One of the big highlights that I want to showcase here, and one of the big takeaways, is the improved reactive power response time. It's going to be around 30 milliseconds from dispatch to receipt. So that's extremely fast for reactive power response time. And then active power ramp rates are going to be somewhere around 60 milliseconds. Our ramp rate and response time on the active power with all of our inverters has always been incredibly fast, and the margin of error of that has been reduced to somewhere below 1%. And all of these tests have been verified by the most rigorous labs, in China. And we also have TUV Rhineland and TUV SUD, as well as DNV and UL verifying these results as well. Now the 250, the 350's predecessor, was the first string inverter that Sungrow released that had the capability of being paired with a DC coupled battery storage solution. The 350 is going to be the same. But right here in this slide, what we're looking at is the PV plus energy storage working together to stabilize the grid along with traditional generation equipment. So, turbines and coal-fired and gas-powered plants, and wind generation as well. Even though it's not traditional, it's still gaining momentum. So if we look back around 2018, we can see that the short circuit ratio of the grid was somewhere around 6 in a lot of these tests, in a lot of these test cases. Okay, so with that current source, what we had to do was adapt to the grid for high and low voltage ride through, and make sure that stability was present there. Last year in 2021, the requirement was for fast dispatch, reliable dispatch, recording, and reactive power support. This is going to still be a staple of the grid support suite that we offer in the command and control software, not only because it's a requirement, but it's really the charter, right? Like I mentioned, of Sungrow, to make sure that we're improving the stability of the grid for users both up and downstream of our projects. And going from 2022 through 2025, we're going to continue to see that short circuit ratio between power conversion and generating equipment and the grid to continue to drop. So what we're going to be looking at is voltage source stabilization. And so we're going to be jointly stabilizing the grid with traditional equipment. And that's because we are in the era of parity, as I talked about in the introduction. The cost, grid parity, we typically think about cost, and this is true, but in a lot of areas of the world, and I think in certain areas of the United States, renewable energy capacity is really starting to get up there with some of the more traditional power generation technology. So we need to continue on that trend, and Sungrow is really making sure that trend is being maintained and honored, and we're going to continue to advance that technology. So the grid parity, as far as cost goes, it has really been realized in a lot of regions here in the U.S., and we're going to continue to operate as good stewards and make sure that advancing and increasing the stabilization of the grid is something that we're continuing to work on. So in summary here, the 350HX as the new upgrade. Here in the North American market, we're really aiming to lower the levelized cost of energy. It's a high power, large block design string inverter that's going to save a ton of money on the CapEx side, just with those two features alone. And the queue at night function, as I mentioned, is going to be, I think, an even more utilized feature of a lot of string inverters. The increased safety that we have built in to the SG350, continuing on with the 2 strings per PowerPoint tracker input, but also the integrated intelligent DC trip switch, as well as the AC insulation monitoring integration, is a huge leap forward. And the multi-dimensional integration, having the inverter optimized for the 182, 210 millimeter modules, really, finding that sweet spot, 1.3 to 1.8 on the DC to AC ratio is going to be realized with 2 different variations of the inverter that are going to be offered. And then we talked about that that tracker optimization, the feedback control loop with the tracker as the inverter monitors IV curve scanning so that we can increase that yield without any additional software or hardware being deployed to site. And grid support. We're really focused on that SCR and stabilizing operation in areas where we have weak grid. We want to be an asset, not a liability. We really want to improve the areas where renewable energy projects are being installed. Okay, I think that's a pretty good introduction here, and I believe that we have about 15 minutes left for questions. So I'll hand it back off to you, Michael.
Thank you Nick. Thank you very much for the fabulous presentation and overview. Do you want to, there were a bunch of questions that were asked. Do you want to address some of the questions? You want to talk through some of the questions?
Yeah, let me get back to that window. Let's see if I can expand it here. Okay, let's go here. Oh, we have an attendee from Libya. It's fantastic. All right. Okay. The first question here is from Kleber. I think I'm pronouncing that right. Kleber. Can the inverter have the option for fewer DC inputs in case of a virtual central configuration? We did discuss that option, but the momentum of the market and the real strength of the design of these high power and high power capacity string inverters is better served by having a direct input architecture. So while we do have customers that are still very much in favor of the single PowerPoint tracker feature with the SG125 HV, the SG350 is still going to be multiple MPPT for distributed generation. Now, that's not to say that you can't have it installed in a virtual central configuration. If your DC runs are going to be longer in that instance, then you may need to invest in some DC optimizers or DC to DC converters to maintain that DC voltage level over long runs. So it's not entirely impossible. It'll just increase the project cost a little bit. Now, I do want to say that the 350 is the antecedent to the SG250HX. So we wanted to maintain kind of the same platform, really geared for those new high power modules. But I really do personally, this is my opinion, I do see in the future another single input, a single PowerPoint tracker string inverter being released into the market for those virtual central configurations. But we'll just have to see kind of where the market goes there. So I hope that answered your question. And welcome, thanks for attending from Libya. That's fantastic. Yeah, the next question is, can you talk more about the anti-PID function and Q at night? How do they work? Yeah, so the PID mitigation function, for those that don't know, PID stands for potential induced degradation. And there are certain types of module construction and module materials that degrade in an ungrounded system. So with string inverters, they're transformerless. That's how they're isolated. They do not have a transformer, so they cannot be They cannot be grounded on either the positive or the negative pole on the DC. Now, what that means for certain types of module constructions that are designed to be grounded on the negative side is that potential, the potential that exists between the positive and negative pole induces degradation in the module material itself. So in order to mitigate that and get more life out of the PV modules, or get the life that the PV modules were designed to have, the inverter can do one of two mitigation functions for PID. The first one is anti-PID, and basically what that does is it raises the potential of the negative pole from a negative voltage value up to 0. Okay, so it eliminates that negative potential to ground during operation. And in order to do that, we have to have a certain transformer configuration, but it's nothing crazy. They're actually a pretty standard vector group and configuration for the medium voltage transformer. The other one is PID recovery, and what PID recovery does is it lets the system operate as normal, ungrounded, without elevating that negative potential to ground during daytime operation. But at nighttime, it remains connected. The inverter remains connected to the DC array and feeds some current back to the array. It's a low amplitude. It's somewhere around 10 milliamps or so. And that is kind of how the anti-PID functions work with the inverter. And Q at night, this is reactive power at night. The inverter is always going to remain connected to the grid at night. It's just a matter of whether or not it's connected to the array based on what kind of PID function it has. But reactive power at night is basically going to give reactive power that's demanded either in inductive or capacitive VARs, depending on what the grid needs. So the inverters as power conversion equipment can provide that reactive power at night as a generation source. Okay. Another question from Asalen is if we have a partner in Libya. I don't know if we do. I know that we do have an EMEA office, so Europe, Middle East, and Africa, and I know that we have projects in Libya. Why don't you send me an email if you could after this, and I can get you in touch with them. Is the inverter housing not aluminum? Sorry, this is the next question. Is the inverter housing not aluminum? If so, will C5 make a difference since aluminum won't rust? Yes, that is true, but the C5 anti-corrosion rating based on ANSI standards not only includes the material that the chassis is made out of, but also the powder coating, the thickness, the material of the powder coating, and what kind of gaskets we have that protect the internal electronics. So all of that kind of combines in concert to give us the C5 anti-corrosion rating. All right, next question from Robert McInnes is why is the AC output at 800 volts and not a more standard three-phase grid voltage as is seen in Canada or the US? That's a great question, and the reason for that is that with the inverters being a higher power capacity, 350 kilowatts, it is designed to be in a distributed generation format. So what I mean by that is we want the inverters basically, if you think about it from a ground mount scenario, we want the inverters to replace the combiner boxes out in the field since they're direct input. So the idea is to have short 1500 volt runs to the inverters and longer AC runs from the inverters to the medium voltage transformer that's on a centralized AC collection skid. In order to mitigate voltage drop over those long distances on the AC side, we're raising the voltage a little bit. There's also the topology of the IGBTs, and in order to achieve the high power in such a small, confined, dense space, we do need to have a higher output voltage on the AC side so that we don't have to be exporting as much current. Okay, so hopefully that answered your question there. Yeah, okay. let's see. Srikanth Madala asked a question, can this inverter be used on projects connecting to the transmission grid? And yes, of course. Yeah, that's definitely not a problem. And more broadly, what is the status of the Trump administration's executive order banning foreign OEM products connecting to the transmission grid for cybersecurity and national security reasons? This is it is kind of a sticky situation, but it's not an issue for Sungrow. Okay, I'm going to repeat that again. This is not an issue for Sungrow. We have not been excluded from connecting to any transmission grid or participating in any projects whatsoever. The executive order from the Trump administration really pertained to equipment that was 69 kV and higher. Now we've complied really with every requirement, and you know, in complying with all of that stuff, we still had a banner year last year. You know, so I don't think it's despite. I think it's in spite of. So for everybody that's still in attendance, there is no concern whatsoever with connecting any Sungrow equipment to the transmission grid. We actually are starting to realize larger market share and the fastest growth rate of any inverter manufacturer that's in North America. Yeah, so that's a good question, and it's something to be mindful of. We do have a director of external affairs that can give you some information on that, but the short answer is that there is absolutely no issue whatsoever with Sungrow equipment. So great question.
Excellent. Thanks, Nick. We have time for one more question. Do you want to pick one more from the group?
Yeah, let's see here. Yeah, I'll do two more quick ones. Does the inverter have pre-commissioning capability to go through setup without the grid? Yes, definitely. That question's from Ben Frank. All we need is DC. All of our string inverters have dual power supplies, so whether it's connected to DC or AC, we're able to do all of the commissioning activities. Really, with string inverters, the biggest and most important commissioning activity is setting up the grid codes and the protection settings, as well as the Modbus ID, in order to establish communications with the data logger and the power plant controller. So as long as we have DC power, that's not a problem. And the 350 will have kind of a closed loop, open loop option. So if we don't have grid, we can still fire up the IGBTs and prove out the rest of the circuit. Now the final question is from Rachel, and she said, when is the inverter available? It's going to be available in Q1 of 2023. So if we can just get through 2022 as quick as 2021 went by, it'll be here in no time. So I want to extend my deepest thanks to everybody that attended from Sungrow. Our deepest thanks from Sungrow, I should say. That came out weird. And CED Greentech for hosting. Thank you so much for giving us the opportunity to introduce the SG350HX to the North American market, as well as the global market for those that attended internationally. It's a huge honor. I look forward to getting some emails from you guys, and don't hesitate to reach out.
Thank you very much, Nick, and thank you to the Sungrow team to introducing the product with us. I'm sure there are other questions. Anyone that's asked a question, we will respond to you. But if you have any questions, please get in touch with our local reps that can answer any commercial questions. If you go to cedgreentech.com, as you see on the screen, /locations, you can find a location near you and start a conversation with us. You can also email us at hello@cedgreentech.com. That's hello@cedgreentech.com, and we will put you in touch with a local salesperson that can answer any questions and continue the discussion about Sungrow's 350 kilowatt inverter. Thank you very much, Nick, and to the entire Sungrow team and everyone who attended with us today. We have a wonderful day.